Hi, this is Dr. Kunka Bheemalingappa, faculty of CSE. I heartily welcome you. In this video, I am going to discuss about design of DFA for a given regular expression. These are the contents that what we are going to cover in this session. First, regular expression, epsilon NFA, and then DFA. In one of the previous class, I have discussed about construction of epsilon NFA for a given regular expression. First, if you want to have the DFA for a given regular expression, you can construct epsilon NFA, and that using that epsilon NFA, you can construct this like a DFA. So let me take a regular expression A or B star ABB. Suppose you have this expression. You are known what is the language that is described by this expression. Any number of A's and B's of any combination followed by ABB. They are the strings that belongs to this expression. So some possible strings of this expression are just ABB. So in every string, at the end you will have this ABB. Otherwise, you may have single A followed by this ABB, or B followed by ABB. Any combination of A's B, like AB or BA, or any combination of this AB, any number of times, ABA, like this, followed by this what? ABB. This is same. So these are the possible strings of this expression. Yeah, for the same expression, now I am going to construct epsilon in FA. The expression is this: A or B star ABB, right? This is the string. You are known how to, in one of the previous video, I have explained about how to design an FA for a given regular expression. If you are not seeing that video, it is better to watch that video before coming to this topic. So anyhow, I am going to explain here also. So this is how you are going to construct epsilon in FA for regular expression. First, what we have here is, that is A and then B, that is ARB. For B part I am writing here. And then for star, what you are supposed to do, you are known. First let me write for ARB. Right, ARB in the sense, for union part you have to introduce a new start state and a new final state. Right now, and you have to give a connection from new start state to old start states on epsilon. Yeah. Now we have completed the part, union part, that is ARB. Now you have, that is a star. For star, what you are supposed to do, you have to introduce a new start state, a new final state, from a direct transition on epsilon, from new start state to new final state, and also epsilon on transition from new start states to, that is old start state, and also old final state to new final state. And also you will have a transition on from old final state to old start state. You are known, before I started design for closure, after completion of completion of the construction for union, this was the final state. So, and this is the start state. So you have to give a transition on epsilon from old final state to old start state. So this part it is completed, ARB whole star. Followed by what? That is A, your known concatenation. Just for the previous part, just you are going to append it. So this is A, this is B, and this is B. So this is going to be our new final state. New final state. So for that, let me use like a different color. That is, this is your final state. Now for all the states, you can give some numbering. That is, this is 0. This is not a final state. Don't get confused. This is state number 0. This is not a final state. This is state 1. This is state 2. This is state 3. This is state 4. This is state 5. 6. This is state 7. This is state 8. This is state 9. This is state number 10. This is state number 10. Is it clearly visible? 10. Yeah, this is state number 10. Okay, before I start the process of designing a DFA for this epsilon NFA, you must be known something about, that is epsilon closure. Epsilon closure. Epsilon closure of a state in the sense, including that state, what are the other states that can be reachable only on epsilon transitions. That is, what do you mean by say that is epsilon closure of a state? Yes. And first let me highlight where do you have this transitions on epsilon. So here you have transition on epsilon, this part. Here also you have transition on epsilon. Here also you have a transition on epsilon. This is also epsilon. This is also transition on epsilon. Right. Let me tell at first, this is a start state. This is a start state. Before that, what are the input symbols that what you have? A and B. If I take the input symbol, say A, right, input symbol A, from what state you have the transition on that A? That is from state 2 and also from state 7 you have transitions on input symbol, that is outgoing transition. From 2 where you are going, that is 3. From 7 where you are going to state 8. In a similar fashion, you also have transition. You are known what are the different input symbols that what you have here. That is input symbol is B. On what states, from what states you have transition on input symbol B? That is state 4, state 8, state 9. So from 4 on B where you are going, that is state 5. Let me use like a different color for this. What color? I think both are same. Let me use like a red color. That is 4 on B, you are going to state 5. 8 on B, you are going to state 9. 9 on B, you are going to state 10. So here 2 on A, you are going to state 3. From from the state 7 on input A, you are going to state 8. Yeah, first you are supposed to start with finding the epsilon closure of the start state. You are known this state labeled with 0 is the start state. So you have to find epsilon closure of 0. So what is the epsilon closure of 0 in the sense? Including that 0, first this epsilon closure of S in the sense, first S is added to epsilon closure of S. So as per that, this 0 is going to get added to this. Right? From 0, what are the other states that can be reachable only on epsilon transitions? Already I have highlighted this part. And also this part I have not highlighted. Okay, let me highlight this. This is also transition on epsilon, you are known, right? Yeah. So epsilon closure of 0 in the sense, from 0, what are the other states that can be reachable only on epsilon transition? From 0, you can reach 1. So 1 can be added. And also from 1, you can also reach, that is 2. So from 0, if you take the path, along that path, you have only epsilon transitions. Therefore, 2 can also be taken. 0, 1, 2. So you are finding epsilon closure of 0, right? So from 0, I have to look. So from 0, you can reach 1 on epsilon, and also from 1, you can reach this epsilon on epsilon. Therefore, this 4 must be added. I think you are following. Yeah. Next, from 0, you can go to this state 7 on epsilon. Therefore, this 7 must be added. This 7 must be added. So epsilon closure of 0 is what? 0, 1, 2, 4, 7. 0, 1, 2, 4, 7. So whenever you find this epsilon closure, you can give some name for that. Okay, epsilon closure. Let me take the name for this epsilon closure of 0 as P. 0 as P. You are known that this 0 is a start state. Then this P will become what? That is start state. Right? Somewhere else, let me directly construct this, okay, transition table also. So your state is a P as of now, and your states are, input symbols are AB. Input symbols are AB. Yeah. So after finding this epsilon closure of a state, what you are supposed to do is, you have to find this A as input. You have to find A as input on epsilon closure of 0. That is, we are calling it as P, right? So A as on P. A as on P in the sense, you are known what are the states that they have this A as input, okay, 2 and 7. Or these 2 and 7 are available in this set P? Yes, 2 and 7 are available, both. Let me show you. 2 and 7 both are available, and you are known from 2 and 7 you can reach the state 3 and 8. Therefore, A as on input, it becomes what? 3, 8. I think you are clear. A as on P, you are going to get what? That is 3, 8. 3, 8. In a similar fashion, you have to find B as input. B as input on P. B as input on P. So whenever you want to find B as input on B, what you are supposed to do? You are known, right? What are the states that they have transition on input B? That is a 4, 8, 9. Of this 4, 8, 9, what are there in this P set? 4, 8, 9. What are there in this set P? That is only 4 is there, right? So from 4, what you can reach on B? That is 5. Therefore, B as input on P, it becomes what? That is 5. I hope you have clear. Yeah. Every time you find this epsilon closure, you can give some name for that. So now you got this, okay, 3, 8, and 5. For this, you have to find epsilon closure. So epsilon closure of epsilon closure of 3, 8 in the sense what? Epsilon closure of 3, 8 in the sense, according to the rule, let me write in the order. Yeah. First, 3 and 8 can be added. Epsilon closure of S in the sense, S is added to epsilon closure of S. As per that, 3 and 8, they are going to get added. So from 3, what are the other states that can be reachable only on epsilon transition? Here you can see, from 3 on epsilon, I can reach 6. Therefore, you can write 6. And also from 6, you can go to this 1 on epsilon. Therefore, this 1 can be added. And also from 1, you can go to this 2 only on epsilon. Therefore, 2 can be added. And also from 1, you can go to this 4 on epsilon. Therefore, this 4 can also be added. I think you are clear. So, what they can be added? Already you are added 3. 3 on epsilon, you can go to 6. From 6 on epsilon, you can go to 1. From 1, you can also go to 2. From 1, you can also go to 4. If you want in the order, let me write here that is 3 and make this, already have written 3 and make it as 4. I think no confusion. Yeah, if you want in the order that you are supposed to do. Otherwise, no need. Let me erase and make it very clear. Yeah, nice. Pen. So 3, that is 4. Let me write this 8 near to this. Yeah, and erase that part. So this is what? Epsilon closure of 3, 8. So what you have got here? 1, 2, 3, 4. Epsilon 1, 2, 3, 4. 6, 8. You can also go to 7 from 6 on epsilon. Therefore, this 7 must also be added. I think you have understood this. See, first you are finding epsilon closure of 3, 8. 3 and 8 were already added. From 3, you can go to 6 or 7. So, from 6, you can go to 7. That is the reason you are supposed to add it. And also, you can from 6, you can go to 1, 2, 4. That is the reason this 1, 2, 4 were added. From 6, you can also reach. You can also go to this 7. Therefore, this 7 also can be included. So, whenever this is epsilon closure of 0, this is epsilon closure of 3, 8. Both are different. So, you can give the name for this as what? Q. Now, you have found epsilon closure of 3, 8 as what? This set. For that, you have given the name as Q. So, here A as input on P, that is 3, 8. So, epsilon closure of 3, 8 is Q, your given name. So, from that is P on A, you can go to this state Q. I think you understood this. P, from P on input A, you can go to the state Q. Yeah, in this fashion. So, if you want, you can make it note of all this, okay, what you are finding epsilon closures. So, what you have done in the earlier case, after finding epsilon closure, you are finding A as input and B as input and that, okay, closure. So, and for that closure, I have given the name as here is what? Q. So, A as on P, A as on, that is Q, not P. A as on Q in the sense, what? What you are supposed to do in the Q, you have to look for transitions on A. Your known transitions on A are what? 2, 7. Are these 2, 7 available in this set Q? Are these 2, 7 available in this set Q, 2, 7. 2, 7 are there in this set. And you are known on 2, 7 you can go to 3, 8. Therefore, A as input on Q, where you can go, what you can get, that is 3, 8. I think it is clear. That is 3, 8. And then B as input on Q. B as input on Q. So, this is Q. You are known. For B as input on Q, what you are supposed to do? What you are supposed to do? You have to look for this 4, 8, 9 in this Q. What are they present? Out of 4, 8, 9, only 4, 8 are present. So, on 4, 8, where you can go? You can go to the states 5, 9. Therefore, this 5 and 9, they must be added for this B as input on Q. Is that clear? Yes? Yeah. What you are going to get? That is 5, 9. Yeah. So, A as input on Q, you have got, that is 3, 8, and you are given a name for epsilon closure of 3, 8 as what? That is Q. Therefore, this is going to be what? Q itself. And B as input on Q, you have got, that is 5, 9, but you have not yet found what is the epsilon closure of this, okay, 5, 9. And also you have not yet found the epsilon closure of, okay, 5. So, right now you have for 5 and, okay, 5, 9. For any one of this time you can go for finding what? That is epsilon closure. Is that clear? Yeah. So, this 5 and 5, 9, okay, are left. So, this time I am going to find what? Epsilon closure of, that is, okay, 5. Now, can you tell me what do you know by say epsilon closure of 5? First 5 must be added, right? According to rule 1. So, you are known epsilon closure of S in the sense S is added to it, and then second rule what it says, from S what are the other states that can be reachable only on a epsilon transition. All those states must be added. So, from 5 what are the other states that can be reachable only on epsilon? From 5, first let me tell you, from 5 on epsilon you can go to 6, 7, right? So, this 6 and 7 are going to be added, and also 1, 2, 4. So, that is outgoing transitions. So, these are the states that you can reach. Therefore, I have shown you, right, this highlighted part. I could have highlighted even this part. This is also transition on epsilon, no? Yeah. So, you are known, right, what are the states that can be reachable. I forgot to. From 5, what are the states that can be reachable only on epsilon transitions? That is 5. From 5, you can also reach 6. That is 5. From 5, you can go to 6. From 6, you can go to 7. Right? From 6, you can go to 1. I am writing in the order. To have the clarity, I am just writing in order. From 1, you can go to 2. From 1, you can also go to 4. Highlighted part. Only on epsilon transitions. So, these are the states that you can reach only on epsilon transition. So, this is what? Epsilon closure of 5. Earlier you were not found epsilon closure of 5, right? So, you were found only with respect to this 0 and 3, 8. So, this is different from that. So, for this, right, you can give a different name. Already have used the names as what? Okay, PQ. So, for this you can use the name as R if you want. Right? So, epsilon closure of 5 is what? 1, 2, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7. That is what this. So, after finding epsilon closure, what you are supposed to do? You have to find same as usual. A as input and also B as input on that, okay, epsilon closure. So, A as input, B as input. So, A as input on, for epsilon closure of 5, I have given the name as R, right? So, A as input on R, what states you can reach? That you have to find. So, you are known A as input in the sense, what states they have? A as input. Two and 7, right? So that 2 and 7, are they available in this R? Both are available. So from 2 and 7, where you can go? You can go to 3, 8. Therefore, A as on R becomes what? 3, 8. Is that clear? 3, 8. 3, 8. B as input on R in the sense what? You are known. What are the states that they have B as input? 4, 8, 9. So in this set, out of this 4, 8, 9, what are they available? Only 4 is available. Only 4 is available. So from, out of 4, 8, 9 in this set, let me show you. Out of this 4, 8, 9, only this 4 is available right in this set. And from 4, you can go to state 5. Therefore, B as input on R becomes what? That is 5. I hope it is more clear. Yeah, that is 5. Fine. Yeah, here you have got that is 3, 8. Already have found epsilon closure of 3, 8, and for that you have given some name, that is Q. Therefore, A on R becomes what? That is Q. A on R becomes Q. I think it is clear. Just now you have found, B on R you have got 5, and already have found epsilon closure of 5. B on R you have got 5, and already have found epsilon closure of 5, and for that you have given the name as R. Therefore, B on R, it becomes what? That is R itself. That is R itself. That is R itself. So, finding this, so right now you have found epsilon closure of 5. For that you have given the name as what? Epsilon closure of 5 you have found, that is R. So here you have that is 5. So for this, so epsilon closure of 5, right? You have to give the name this as what? That is R itself. So here you have to write that is R. Let me write. So here what I have to write? That is R itself. Yeah. So P on A already have written Q. So P on B, this time you can write that is R. I think you have got it. You are known, right? What are the different states you have? You have given, have the different states P, Q, R you have got, okay, as of till now. So next, Q on A. Q, that is epsilon closure of 3, 8, you are calling it as a Q, you are known. So A as on Q, that is okay, Q itself. So A as input on Q, you are going to state okay, Q itself. And also, B as on Q is 5, 9, but you have not yet found epsilon closure of 5, 9. That's what you are supposed to do now. You have to repeat this process as long as you have this different states. At some point of time, you are going to find that you are going to get same set of states. Then that is a sign indicating that time to stop. So this time we can find epsilon closure of 5, 9. Epsilon closure of 5, 9. So what do you mean by say epsilon closure of 5, 9? Epsilon closure of 5, 9. I hope by this time you have become familiar with that is epsilon closure of state or say okay set of states, right? So what the rule it says? First you can add this 5. After this 6, 7, 8. For that I can give some space. I don't know whether I am getting that or not. And also that is okay 9. Okay, let me write that okay 9. Before 5 also have some space. Okay. So you are known 5, 9. From 5, what are the states that can be reachable? From 5, what are the states that can be reachable? Already you are known 5, 6, 7, 1, 2, 4. Therefore, you must add them, right? So what you are supposed to add? 5, 6, 7, right? And then 1, 2, 4. 1, 2, 4. So, and from 9, do you have transitions on only on epsilon? No. So this is epsilon closure of phi 9. Epsilon closure of phi 9. So this is different from others. That is PQR, right? So for this, right, you have to give a different name. Let me take this name as what? Say yes. Say yes. Now you have found epsilon closure of phi 9. For that you have given the name as what? Yes. Therefore, for this, right, you have to give the name as what? Yes. So now Q on B, that is Q on B, you can give this, okay, state name as yes. I think you understood. For P, Q over. Next, R. From R on A, where you can go? Do you want me to show it? From R on A, you have got Q. Therefore, you have to fill here. You have filled that entry. R on A is Q. And also R on B is R on A is Q. R on B is R itself. You have to fill those, okay, entries in the table. Right. So R on A is Q. R on A is Q. R on B is R itself. R on B is R itself. Fine. So after finding the epsilon closure, what you are supposed to do? As usual, after finding epsilon closure in the previous cases, what you have done, you are known, right? So A as input and B as input. So A as input on, what is the name? That is yes. And also B as input on yes. So A as input on yes in the sense, A as input on the yes in the sense. So A as input, right? So you are known 2 and 7 are the states that they are having transition on A. Are they available in this? Both are available. 2 and 7 in the sense you can go to A as on yes. A as input you have 2, 7. In this yes, that 2, 7 are available. And from 2, 7 you can go to 3, 8. Therefore, A as on yes you are going to get, that is 3, 8 itself. 3, 8. Where is it? 3, 8. Next, B on yes. The same explanation, okay, follows. You are known 4, 8, 9 are the states that they are having transition on B. In this yes, of these 4, 8, 9, which are available? 4 and 9. Only 4, 9, 8 is missing. So from 4 you can go to 5, from 9 you can go to, that is 10. Therefore, it becomes what? 5, 10. So B on yes, it becomes what? 5, 10. 5, 10. I think you are clear. Yeah. So this is over. A as on yes, B on yes. And what you are left? Already you have found epsilon closure of 3, 8, right? And you are known for epsilon closure of 3, 8 is Q. So this becomes what? Q. And you have not yet found epsilon closure of phi 10. This is new set of state, right? So this time you are supposed to find that epsilon closure of 5, 10. I think you are clear. Yeah. So epsilon closure of phi 10 in the sense what? 5 and 10 added at first, right? Yeah. 5. Let me write 10 at the end. Yeah, you have only 10 states, right? Yeah. From 5, what are the states that can be reachable only on epsilon transition? Already were known, so many times I have referred. 6, 7. From 5, what are the states that can be reachable only on epsilon? That is 6, 7, 1, 2, 4. Therefore, they must be added. What must be added? 5 it is already there. 6, 7, 1, 2, 4. 1, 2, 4. So from 5 that is fine. From 2, can you go to any other state on epsilon transition? No. So this is epsilon closure of phi 10. For this you can give a different name. See, for epsilon closure of 0, P have given, 3, 8 have given Q, for 5 have given R, for phi 9 you have given S, for phi 10 this is a different, therefore you can give some name for this. I am giving the name here it as, that is T. Okay, T. So next what you have to do? A as input on T and also B as input on T. Right. So A as input on T in the sense, you know what is this T? T is this 1, 2, 4, 5, 6, 7, 10. A as input on T in the sense, A in the sense 2, 7. Are they available? Both are available. From 2, 7 where you can go? 3, 8. Therefore this A as A on T becomes what? That is 3, 8. So shall I write that? It becomes 3, 8. Similarly, B on T. B means 4, 8, 9. So of this 4, 8, 9, what are available here? Only 4 is available. 8, 9 are there in the set T. So from 4 where you can go? That is, A on T, this is a set. So for B, you have to look for 4, 8, 9. Of this 4, 8, 9, only 4 is available. From 4, you can go to 5. Therefore, this 5 must be added here. So B on T, it becomes 5. That's all. Yeah. Already you have found epsilon closure of 3, 8. For that you have given the name as what? Epsilon closure of 3, 8. That is Q. So it becomes a Q. Just now you have found epsilon closure of phi 10. For that you have given the name as T. Therefore, B as input on S, it becomes, that is a T. Next, already you have found epsilon closure of 5. For that you are given the name as here you have 5. You have to find epsilon closure of 5. Already you have found. For that you have given the name as R. Therefore, B on T becomes what? R. So it becomes R. That's all. So all are covered. You don't have write any more, okay, new states. So that is this is a time to stop. So you are known, right? What are the different states that what you have? That is P, Q, R, S, T. They are the names, right? That what I have used, right? So already for P, Q, R part, I have shown the table. In a similar fashion, I have to show it for S and T. So this is S. S on A is Q, S on B is T. You fill that in the table. It becomes easier at the time of drawing the transition diagram. S on A is Q, S on B is T. Similarly, A as input on T, that is Q, you have to fill. See here. A as on T, that is Q, B as on T, that is R. Therefore, I have to fill the entries as Q, R, okay, respectively, for T on A and B. That is Q and R. So this is the transition diagram. This is a table. From this table, you can get this, okay, diagram. Yeah. You are known, this 10 is a final state. This 10 is a final state, right? So of these states, you have 5 states, P, Q, R, S. Of these states, which has this 10 will become a final state. Is there a 10 in this P? No. Is there a 10 in this Q? No. Look for that 10 in this R. It is not there. In S, is it there? No. In T, is it there? Yes. Here you can find that, okay, 10. Therefore, you have to treat that, okay, T as a what? Final state. You have to treat that T as a what? Final state. That is this. You are known, final or accept states are denoted with, okay, double circle. And you are known for epsilon closure of start state, what the name you are given, that will become a start state here. You are known, your start state here is, start state is 0. Epsilon closure of 0, I have given the name that is P. Therefore, P will become the, okay, start state. I think you are clear. So, this P is the start state. P is your start state. So, this is a DFA, I can say. If you want to draw the diagram, okay, using this table, you can easily draw and you can verify. Shall I draw that, okay, diagram? Yeah, I know, right, what are the states I have? Let me make it fast. Yeah, this is, okay, P. That is start state. P on A, where you can go? P on A, you can go to state Q. P on B, you can go to state B. P on B, you can go to state R. States are denoted with capital letters here. Yeah. Q on A, you can go to Q itself. Q on B, you can go to S. So, P, Q, R over. Next, look at R. R on A is Q itself. It is this. R on B is what? R itself. Yes, on A, you can go to Q. That is this. Are you getting? T on A, you can go to Q. S on B, you can go to T. I have not yet introduced that. Sorry, S on B, you can go to T. So this T is a what? Final state. From T on A, you can go to Q. That is this. T on B, you can go to state R. And you are known this T is a final state. So let me double circle this. This is how you can convert regular expression to DFA. So what is the procedure that you are supposed to follow? First, you can convert that regular expression to epsilon in FA, and then from epsilon in FA, you can get this DFA directly in this way. So this is a two-step process, right? First, you can design epsilon in FA as per these rules, and then by using the procedure that what I followed on that epsilon in FA, you can get this DFA. Thank you for watching my video. Wish you a good day.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.